In this video, we'll be talking about indefinite integral. As we all know that there are many methods in which you can use for indefinite. Now, I'll be showing you how to use DI method. When we're talking about DI, we're talking about differentiation and integration. So as for us to know what we'll be talking about, these are some set of examples that we'll be solving. But before we go further into this example, let me give you instinct about what we want to talk about. Let's assume you want to integrate x raised to the power 3 multiplied by x raised to the power 2. Now, we're going to use DI method in this place. DI. You'll be the one to pick the one you want to differentiate and the one you want to integrate. Now, in this one, I want to differentiate x squared and I want to integrate x3. The reason why I want to integrate x cube is because if I differentiate this one, I will get 0 as fast as possible, and if I integrate this one, I'll be able to get more power. Now, when you differentiate, you have 2x. When you integrate, s4 over 4. When you differentiate again, you have 5 over 20. When you differentiate, you have 0. You have x is over what? Over 100. But we don't need this aspect. We don't need this aspect. Then let's do the next thing. You multiply this, you multiply this. So don't forget, you have to add plus, minus, plus. So we multiply x squared multiplied by x raised to the power 4 over 4 minus 2x multiplied by x raised to the power 5 over 20 plus, we multiply this part together. That will give you 2 dot x raised to the power 5 over 20. But don't forget, you still have to integrate the last part. Same, we have x raised to the power 6 over 4 minus 2 raised to the power 6 over 20 plus 1 over 10 integral of x raised to the power 5. Then we have over 4 minus x raised to the power 6 over 10 plus x raised to the power 6 over 60. So when you find the LCM, we have the LCM to be 60. So here now we have 15 x raised to the power 6 minus 6 x raised to the power 6 plus x raised to the power 6. So we have 15 minus 6 plus 1. We have 10. That will give us 10 x raised to the power 6 divided by 60. We have what? X raised to the power 6 divided by 6 plus c. That is what DI is talking about. Now, how do we check? Just for us to know that this method is very right, you can see that this can be written as x raised to the power what? 3 plus 2 dx. Then x raised to the power 5 dx. If you integrate this, plus c, you can see. So we'll be using this DI to solve at least 3 of these ones. Now let's solve our example 1. Solution DI. Now the question is, which one do you think you can differentiate here? I would love to differentiate x, and I would love to integrate what? Cos x. Why? Because if I differentiate x, I will have 1. So that one is vanished. So let's differentiate 1. If you integrate cos, you have what? Sin x. Don't forget, we have plus, minus. What is the next thing? You multiply this one. So we have plus x sin x minus, you integrate. When you want to multiply this, you integrate it, minus sin x dx. So we have x sin x minus, when you integrate this, you have minus cos, which will give you cos x plus c. That is the first one. Now going for the second one, integral of x squared e raised to power x dx di. Which one do you think we can differentiate? You will differentiate x squared, because if you try to differentiate this one, you just notice that it will just be giving you the same number, the same number, the same number. X raised to power this. When you differentiate this, we have 2x. Integrate, we have vx. Differentiate, we have 2. We have vx. So plus, minus, plus. You multiply this one. You multiply this one. So plus x squared ex minus 2x ex plus integral 2ex. So x squared ex minus 2x ex plus 2ex. So if you factor ex out, ex raised to power x squared minus 2x plus 2 plus 1 plus c. That is the solution to the second example. So now we want to use di to solve this thing. Di. Now I would love to differentiate ln x. Now it will come to your mind that what do I want to integrate? I can say ln x is the same thing as saying ln x multiplied by 1. So the next thing for me to do is just to put 1 here, then I will integrate this. If you differentiate this, we have 1 over x. If you integrate this, we have 1. Now I must tell you this, that in all the example we have been doing, you notice that we stop somewhere. How do you know where to stop? How? Now let me show you. Whenever you are doing this kind of thing and you notice that, look at this point, you notice that if we differentiate this thing again, it will turn to 0. You can stop. You stop here. You stop here. If you check this one too, if you differentiate 1, you have 0. You stop here. That's the first point. The second point is, in this kind of thing now, if you differentiate this thing, you can never get 0. If you differentiate 1 over x, you can never get 0. So what do? For you to know that, okay, I can stop here, look at the multiplication. If you multiply this thing together, it will give you 1 over x times x. That will give you what? 1. You can notice that if I integrate this 1 now, I will have x. I can stop. So if when you multiply these two together, you have simple thing to integrate, you can stop. So we multiply that. Don't forget plus, minus. Then you add your plus x ln x minus integral of 1 over x multiplied by x dx. Then you have x ln x minus integral of 1 dx, x ln x minus x plus what? Plus C. So that is how to use DI method. Please, I will be leaving this one and this one into the comment section. Please try to solve and share me the answer. If you have not subscribed to my YouTube channel, please do so. Subscribe, like, share this video to your friends, comment, and learn. Thank you. God bless you.